Students, hope you are doing well. I'll start a new video with the same chapter, that is surface chemistry. In this video, I'll start with the classification of colloid. So as I mentioned in the last video, the colloids are classified based on different factors. So the first factor of classification which I have taken is the physical state of dispersed phase. dP dispersed phase, dm dispersion medium. So there are different types of physical states like solid, liquid and gas. So based on the physical state, they are classified as, you can see from the table, if the dispersed phase is solid, dispersion medium solid, then the colloid is known as solid salt. An example of such a colloid is colored glass. Now, if the dispersed phase is present in solid form, dispersion medium is in liquid state, the colloid is known as salt. Example is pen. If the dispersed phase is solid, dispersion medium is gas, the type of colloid is known as aerosol. An example like smoke, dust. If the dispersed phase is liquid, dispersion medium solid, the type of colloid is known as gel. Example cheese, butter. If it is liquid, that is dispersed phase, dispersion medium is also liquid, the type of colloid is known as emulsion. Example milk. So we have liquid dispersed phase, gas dispersion medium, aerosol. Example fog. Gas dispersed phase, solid dispersion medium, solid salt. Example foam rubber. Gas dispersed phase, liquid dispersion medium, foam. Example froth. So this is an important table. From here you'll be asked the questions like, what is the dispersed phase and dispersion medium in gel? So what is the dispersed phase? Liquid, dispersion medium, solid. Or what is the dispersed phase and dispersion medium of milk? So what is the dispersed phase? Liquid, dispersion medium, liquid. So you'll be asked the dispersed phase and dispersion medium of different types of colloids. Or maybe from the example, like what is the dispersed phase and dispersion medium of dust? So this topic is important. Let us see the next classification. The next classification is based on the nature of interaction. Nature of interaction between dispersed phase and dispersion medium. Now say this is a dispersed phase and this is dispersion medium. These two particles, they can have the force of attraction or maybe force of repulsion. That means they may have liking or disliking. So depending on this, we have classified colloid in the two types, that is lyophobic and lyophilic. We know phobic. Phobic means a kind of phobia. So here, the dispersed phase particle dislikes the dispersion medium particle. So the colloids where the dispersed phase and dispersion medium particle has got disliking for each other is known as lyophobic colloid. So in this kind of colloid, since it's very difficult to keep the dispersed phase particle and dispersion medium particle together, we need a stabilizing agent. Whereas lyophilic, philic means liking. So in lyophilic colloid, the dispersed phase and the dispersion medium particle, they like each other. So in case of lyophobic, disliking; in case of lyophilic, is liking. Next classification is based on particle. Based on particle of dispersed phase. So first is multi. multi-molecular colloid. Now multi means many. So in case of multi-molecular colloid, initially the size of the particle is less than 1 nanometer. Now since it's less than 1 nanometer, it's not considered as a colloid particle, but when these particles are dissolved or added to a suitable solvent, they form an aggregate. That means they come together and form a bigger size particle, which is in the colloidal range. Now these particles are in colloidal range. So such colloids are known as multi-molecular colloid. So in multi-molecular colloid, initially the particle size will be less than 1 nanometer, but due to formation of an aggregate, the size will come in the colloidal range. Such colloids are known as multi-molecular colloid. Next is macromolecular colloid. Now we have seen in case of multimolecular, the size of the particle initially is less than 1 nanometer. But in case of macromolecular, the size of the particle is greater than 1000 nanometer. So since it's greater than 1000 nanometer, if you have to convert it to a colloidal particle size, what do you have to do? We have to break this particle into smaller parts. So what we do in case of macromolecular colloid, a big size particle whose size is greater than 1000 nanometer is broken to form particles which is in the colloidal range. That means these particles are in colloidal range, that is between 1 nanometer to 1000 nanometer. Such a colloid is known as macromolecular colloid. So multi, the size is less than 1 nanometer, but on formation of aggregate comes in the colloidal range. But in case of macromolecular, is more than 1000 nanometer, on breaking comes in the colloidal range. Now the third type, based on the particle of dispersed phase, is associated colloid. Now associated colloids, when we take low concentration of substance, it will act as a strong electrolyte. When we take at a low concentration, it will act as strong electrolyte. But if we increase the concentration, that is at high concentration, it will form an aggregate and will act as colloid. So such a colloid is known as associated colloid. Now the aggregate which is formed on increasing the concentration is known as mycelium. So let us see the formation of mycelium with the help of soap solution. Now, soap solution, I'm sure you know the structure of soap. Soap is defined as sodium or potassium salt of long chain fatty acid. C17H35 COONA. So this is a long chain fatty acid and it's a salt of either sodium or potassium. Now in a soap you'll have two parts. One is hydrocarbon part and the other one is ionic part. That is polar and non-polar. Now the hydrocarbon part, that is the non-polar part, is soluble in oil. That is, it's hydrophobic in nature. The non-polar part, they dislike water. They have got liking for fat, oil, but they dislike water. Whereas the polar part, that is COO negative Na positive, is hydrophilic. That means they are soluble in water. So first you have to know a soap has got two parts, polar and non-polar. The non-polar part is soluble in oil and the polar part is soluble in water. Now when we take a dirt particle, so let us take a dirt particle, this container containing water. So there is a dirt particle here. Now when we'll take the soap solution, the hydrophobic part gets dissolved in the dirt. Dirt is usually oil particle or grease. So the hydrophobic part, that is the non-polar end, that is tail part of the soap, gets dissolved or gets soluble in the dirt particle. Whereas the polar end remains suspended in water since they are hydrophilic in nature. So there will be more number of soap particles, like the non-polar end will be soluble in oil and the polar end will remain suspended in water. So this is how a mycelium is formed. Now, this mycelium, the particle here formed, cannot form aggregate. The reason being, the positively charged sodium, which is suspended in the water, it will repel the incoming particle, the particle which comes closer to this particle. So there is no possibility for the formation of an aggregate. So that is how a colloid, that is associated colloid, if you take low concentration of a substance, it will act as strong electrolyte. But if you take high concentration, it will form a colloid. And this colloid, this aggregate is known as mycelium. Now, this mycelium is formed at a specified temperature. And the temperature is known as Kraft temperature. So this is the classification of colloid. So in the next video, we'll study about the preparation of colloid. Thank you.